Hello guys, this is another tutorial from Codeworks. In this tutorial I'm going to code the Radix sort. In my previous tutorial I discussed Radix sort algorithms planning, how it actually works. In this tutorial I'm not going to discuss that. I am going to directly jump into the code. I'm using code blocks here, and I've been working on a previous file radix.c where I was practicing a bit. It's my second try now, and I've not memorized or anything, so I'm going to make mistakes, and I'm going to show you how to rectify them as well. So let's first save it as okay, let's save it as radix sort dot c. Okay, radix sort 2.c, radix sort 2.c. Let's start by including the header files. Include stdio.h hash include coniu.h. It's not very important, but I included it this time. Then hash include stdio.h. Okay, unlike other tutorials, I'm going to discuss the main function now. It's int main, and actually I'm going to show you the array. For that reason I started with int main this time. Let me increase the font. Now you can see better, I guess. Int ar, number of elements, let's suppose let's take 7, and the elements suppose 2, then 10, then 22, then again 2, then again 22, and 6, then 8, then 8. How many elements? 1 2 3 4 5 6 7 8. Okay, 8 elements is good. This is my array. This is my array here, and I'm going to show you something here. How to print the size of an array, means how to get the size of an array. Let's see if it works. N equal to size of ar by size of ar subscript 0. Let's see if it works. Printf %d n. Let's just see if it works, and it works. Yeah, well, unlike other programming languages such as Java or C Sharp, there they have the dot length property, means it would be ar dot length. But in C there is no such ready-made function like that, so we have to find the size of the array in this manner. It's size of ar by size of ar subscript 0. It can be replaced with any other byte element, say 2. It should work as well. Yeah, it's okay. I think last time you couldn't see here. It's 8. It's coming 8 here. Okay, let me show you the 0 again. 0 F9 Here it's 8 here. Number of elements is 8. So this can be replaced with any other valid element. 1, 2, 3, 4, 8 elements here. So this can range from anything from 0 to 7. It's something more than 7, then what happens? Say 9. Okay, it still works. Okay, let's not deviate from our topic. So this way you can print the you can get the size of the array in C. This is another bit of information which you got apart from this Radix sort. Let's give proper name, say size. Okay, now um, let's call the radix sort function. Radix sort the array ar comma size. Yeah, okay. Then we define the radix sort function now. The radix sort would just sort these elements. um, it would not it should not return any value here. So it will be void radix sort, void radix sort integer array ar comma temp size. Now to find the biggest element of the array, int big, or okay, let's find the size of the biggest number in this array. Let's say m equal to big ar comma size to find the biggest element in this array. So let's make this function int big, int because it would return an integer, the number of elements, int ar comma int size. Okay, now it would run throughout the loop, throughout the array to find it. Int say temp equal to ar subscript 0, the first element. Then for I equal to 0, I is less than size I plus plus, if ar subscript I, the ith element of array, is greater than temp, then temp equal to ar subscript I. If the ith element of array is greater than temp, then temp equal to ar subscript I. So this for loop would find the largest element of the array, then to find its length. For this let's define I here, comma I comma length 0 initially, length is 0 initially, and while temp is greater than 0, length equal to length plus 1, then chop a digit of temp equal to temp, chop a digit of temp, then continue. Yeah, this should give the length of temp, the number of digits of temp. After getting the length, just return this. Okay, just return it, return length, return length. Okay, yeah, return length. Okay, now this function would return the number of digits of the biggest number in the array. Here m, it will be stored in m in this function. Now it will run a for loop here. Int I equal to 0. Let's say for I equal to 1, I, not I, m by I greater than 0. I plus. The reason for doing this is initially I equal to 1, then I, not plus plus, I equal to I into 10, I into 10. Okay, initially I equal to 1, then I equal to 10, then I equal to 100. In this manner we can extract the digits from LSB to LSB. That's why it's done like this. And when m mod m divided by greater than 0, means when m is 2 and I is 1, 2 by 1 greater than 0, yeah, it will be run. When I equal to 10, mi set is 2. Wait, there's some problem here. Wait, actually I think we should modify the big function here, because what I'm thinking is in this radix of function I equal to 1, let m divided by I. Actually I need to extract the digits based on I, so I can't be 1 2, it has to be 1 then 10 then 100. Actually I don't need to find the length here, I will just chop it at this position here. It will be m by I. So if m is the biggest size, biggest number of the array, then m by I would serve a purpose. Suppose the biggest if m is 410, then 410 by 1 is greater than 0, so loop would run. And m is 410, then 410 divided by 10 is greater than 0, so loop would run. Then 410 divided by 1000 is less than 0, it's 0 actually, so loop would not run because the condition says it should be more than 0, but it's less than 0. It's not less than 0, it is equal to 0, so loop would stop running. So we don't need to find the length of the array, we just need to return the biggest element. Just return 10. You need this part. Return 10. Okay, now let's call the sorting function count sort the array of size would come from here, and I. Okay, yeah, this is it. Now let's define the count sort function. count sort would not return any value, no return any value. Yeah, so it's void count sort int ar int size int I should write here exponent. Actually it's exp, it's exponent here. Okay, now I adjusted the size a bit because it's not fitting properly. Okay, now if you recall from my previous tutorial, we have to make three arrays here, three array arrangement. The first array would first array is count of size 10 equal to, means each element of this array, each element of this array would be initialized to 0 here of this, because of this line. But this first array would do, it would find the occurrence of each element of the array, original array AR, find the occurrence of each element of the original array. Okay, for I equal to 0, I is less than size of the original array, I plus plus, then we have to take into consideration the first element, not the first element, sorry, the least significant digit of each element. Now the least significant digit can be extracted in this manner. Suppose this least significant digit equal to AR subscript I, the ith elements divided by exp. It's not the exponent, I'm sorry, it's not the exponent. It's a sort of a number which I would use to get to the required digit. If exp is 1, then suppose the number is 10, 10 by 1 is 10, then this thing 10 by 1 is 10, then 10 mod 10 is 0. So this would give this would give the last digit of 10, means the least significant digit of 10, that is 0. If the number is 10 and exp is also 10, so 10 by 10 is 1, 1 mod 10 is 1, so it would give the second digit of 10. In this way exp is used. So this is least significant digit, I'm getting the least significant digit. Actually I should not write least significant digit, because least significant digit is only in the first iteration of this form, first iteration of the loop in Radix. So when I equal to 1, then it would be LSD, as not be LSD theoretically. Okay, but for demonstration's sake I'm saying it's LSD. LSD equal to AR subscript I divided by exp mod 10. Now in the count array, count least significant digit equal to count least significant digit, whatever the value, plus plus. This way we count the number of elements. No, we don't count the number of elements. We count the number of occurrence of each digit. If there was initially 0, then after this element it becomes 1. There was 1, it becomes 2, and so on and so forth. Now after this array is done, if you remember from my previous tutorial, it said you would declare another array. Okay, let me write I here. I would forget. we have to declare no, we don't have to declare another array. We have to readjust this count array so that we find the number of elements less than or equal to the concerned element. For I equal to 1, I less than size. In a minute you will understand why I wrote I equal to 1 and not 0. I plus plus, then counts I equal to counts I plus counts I minus 1. So whatever is the earlier elements, it would then whatever be the value of the previous element, it would take it, would take the value of the current element, add them and store it in the current element. It would take the I minus 1th element, take the value of the ith element, add them and store it in the ith element of count. I took 1 here because if it was 0, then 0 minus 1 would give minus 1. Negative array index does not exist, so an error would occur. So I wrote here I equal to 1. It starts from 1. So this is it, the second pass, I mean for second array. And now for the final array. And then I need another array here, say result of size here, okay, here size here, then for I equal to size minus 1, size minus 1, I greater than equal to 0, I minus minus, I minus minus. Okay, now what I'm going to do is I'm going to go to the initial array, the AR initial array, and I'm going to take the elements from the last, find its position in the count array here, find the position in the count array, and from there I'm going to find the correct index. Okay, suppose the LST equal to this thing here, shift and control C, copy this part, same code here, that's right, paste it, ARI, I equals size minus 1, okay, divided by exp, not 10, this is LST, then my index equal to LST minus 1, because array index starts from 0, then result of index, no, result of yeah, result of index equal to it would, index would be count of LST minus 1, result of index would be AR subscript I. The reason for it being LST AR I, okay, what this would be to is, suppose we had 5 here like this, or say 15 here like this, then ARI suppose is 15 divided by exp is 1, 15 by 1 is 15, not 10, means it would give 5, it would give 5. So index equal to count 5, and in the 6th position of index 5, Now, what this would give? This would give at the sixth position, means at index 5, the number of elements less than or equal to 5. This is what it does. So we would take that value and subtract 1, because array index starts from 0, not 1. So subtract 1, then results index would be ARI. This is the correct position of this element, um, is this index. So results index would be set to this value. This would continue for all the elements, and after this what we have to do is set this value to the original array, yes, then size I plus plus ar I equal to result of I. Okay, the original array is sorted here partially, so this is it. So let's print this array now. For I equal to 0, I is less than size I plus plus printf %d, this is an integer, ar subscript I. Let's cross our fingers and let's run it. There's a problem here. Let's see what it is. It says index was not declared in this scope. Okay, yeah, let's declare it then. Comma index. Let's run. I was not declared, obviously. Let's declare it. Okay, see, it does not give us the proper result, so let's debug it now. What was the problem? Let's find out. Okay, just for debugging purpose, let's print the value of m here. Printf %d/n comma m here. Let's print it. Let's see. M gives a 22. And my biggest element is int 22, so m works here. Shift here. Okay, so big function is okay. Then okay, to check this count sort function now. Let's print this result array here. Let's see. For I equal to 0, I less than size I plus plus printf %d comma result I. Okay, let me give a let's give a dummy printf function here. Printf /n. Let's run it. Okay, 10 here. Wait. So it's 10 8 2 0 2 6 048. Well, what is this 48 here? 1 2 3 4 5 6 7 8. This is 48 coming. In my array there is nothing known as 48. So this is 48 coming. Okay, let's do something. Let's copy this code. Let's print this array before doing anything at all. Means as this function is got it, let's print it. Okay, let's see. As you can see here, something is not right. Something is not right here. What I think is these big numbers which you can see here, these are actually the location. Location. Okay, please pause this video, debug this application, sorry program, and I'm going to get back to you.